ask me later on, you can always ask me. Okay, no problems. Right, so let's continue our lessons. I already put in your Google Classroom about this week's videos about motion. So have you watched it or not?
Not
Not
yet.
yet, not yet.
Nope.
Okay, great. Okay, you can right now. I think everybody can go on your own. Okay, or you want me to play the video? It's up to you. I can do both. Which one do you prefer? You want to play it on your own for half an hour, and then of course, I can also play it to you here. Okay, which way? Any way I can. Huh? Anyone? Do
So
you
maybe you can
prefer?
play it for us.
Oh,
Yes.
play it for you. Okay, now okay. So let's look at this today's video about topic 2.1, chapter 2.1.
Welcome and good day, students. Today, let's talk about physics in mechanics, focusing on motion in one dimension. So we are going to start with identify all the subtopics in the chapter 2. Let's begin with the first subtopic 2.1, discussing about parameters involved in a linear motion, such as displacement, velocity, and acceleration. 2.2 is about motion diagrams. 2.3 is one-dimension motion with constant acceleration. And lastly, 2.4 is free-falling object. But the subtopic 2.4 will be discussed on the next video. In order to study all the subtopics given, there are 4 learning outcomes need to be achieved by the student at the end of the session. Number 1, students should be able to define all the parameters for the motion in one dimension, such as position, distance, displacement, average speed, average velocity, and average acceleration. Number 2, students should be able to calculate all the parameters involved in the linear motion. Number 3, students should be able to apply 4 kinematics equation of motion with constant acceleration when solving the problem. And last one, number 4, students should be able to sketch, analyze, and use the graph of displacement versus time, a graph of velocity versus time, and last one, a graph of acceleration versus time when solving the problem related to a body with a constant acceleration. Motion involves the displacement of an object from one position in space and time to another position. To explain about this motion, we require a coordinate system with a specific origin. Position can be defined in terms of one frame of reference. It is a choice of coordinate axis that will define a starting point for measuring the motion. In this chapter, we focus on one-dimensional motion only. So you may choose your motion either along x-axis or y-axis. For example, an athlete walks along x-axis as shown in the figure. A displacement is defined as the change in position between initial and final position. It is symboled as delta x. To calculate the displacement, you may use the formula as displacement delta x equals to final position xf minus initial position xi. The SI unit for displacement is in meter. Displacement is an example of vector quantity, but distance is the total length of travel object. It has the same SI unit with the displacement, which is in meter. This is example of displacement. We have two situations given. The first situation is from point A to point B. For example, if the car moves to the right from position A at 30 meter and stop at position B, which has 52 meter, the displacement of the car, delta x, becomes positive 22 meter. We say that the displacement is positive, and this indicates the motion was in the positive x direction. Meanwhile, The second situation is from point C to F. For example, if the car moved to the left from position C at 38 meter and stopped at position F at negative 53 meter, so the new displacement delta x of the car now is negative 91 meter. We say that this displacement is negative and indicate the motion of the car was in the negative x direction too. Any measurement of object can be classified into two groups of quantities. The first one is scalar quantities, which are completely described by magnitude only, for example, speed and distance. The second group is vector quantities, which need both magnitude or size and its direction. For example, displacement, acceleration, and velocity. Speed is a scalar quantity. For example, Ahmad drives his car at a speed of 90 km per hour. The SI unit for the speed is meter per second. What is average speed? Average speed of an object is defined as the total distance traveled divided by the total time elapsed. By the formula, you may write average speed v equals to path length d over total time taken t. Average speed totally ignores any variation in the object's actual motion during the trip. Both magnitude of path length and the total time taken are always positive. As the result, the speed or average speed also will become positive. The SI unit of the average speed is meter per second. So now, what is the difference between the path length and distance of a moving object? The distance is the length of a straight line joining between the 2 points. The distance depends only on the endpoints, but doesn't depend on what happened between these points. So we can say that distance is the magnitude of displacement. However, the path length or total distance traveled is the length of an actual path traveled across between the 2 points, including any retracing of the step. The path length will depend on the actual route taken during the trip. Velocity is a vector quantity having both magnitude and direction. When a moving object undergoes a displacement and takes time to move, we say that the object has a velocity. So that velocity can be both positive or negative regarding to its direction. The total time taken during the motion must always positive. Average velocity is the rate at which of displacement occurs. By the formula, you may write average velocity equals to displacement delta x over change of time delta t, or displacement delta x equals to final position xf minus initial position xi divided by final time tf minus initial time ti. Average speed is not same as average velocity, but these two quantities has the same SI unit, which is in meter per second. Average velocity is also a vector quantity. It tells us how far something is moving with the direction of the object. If an object is moving in the positive direction, the magnitude of average velocity is greater than 0. This is because of the final position must be greater than initial position. Otherwise, if an object is moving in the negative direction, you may get the average velocity less than 0. This is because of the final position now must be shorter than initial position of the object. Velocity can be determined from position versus time graph. We plot position x on the y-axis and time t on the x-axis. The magnitude of average velocity equals to the slope of the graph. If an object is moving with a constant velocity, the graph shows a straight line. To calculate the slope of the graph or the average velocity from the graph, the student may use the formula as the change in vertical axis, delta y, divided by the change in horizontal axis, delta x. When the moving object changes its velocity, we may have a curved path graph. This motion is called as non-constant velocity. Therefore, a position versus time graph is not a straight line graph due to the changing of the velocity. The magnitude of average velocity is the slope of the graph. To having this, student needs to draw a straight line from initial point to final point, as shown as the blue line on this graph. The instantaneous velocity can be defined as the average velocity in the limit as the time interval becomes infinitesimally short. The magnitude of instantaneous velocity can be calculated from the slope of the graph displacement x versus time t. The slope of the blue line shows that the average velocity which approach the slope of the green tangent line, which is the instantaneous velocity. Next is acceleration. Acceleration is symbolized by small a. By definition, it is changing of velocity, or we may say that acceleration is the rate of change of the velocity. To calculate the acceleration, we may have the formula acceleration A equals to change of velocity delta V divided by change of time delta t. Or you may write as acceleration A equals to final velocity Vf minus initial velocity Vi over final time Tf minus initial time Ti. The SI unit of acceleration is meter per second squared. You may also use the others unit such as centimeter per second squared and feet per second squared to indicate the acceleration. Acceleration is a vector quantity having both magnitude and direction. When the velocity and acceleration are in the same direction, then the speed of the object will increase with time. Therefore, the object is speeding up. Otherwise, when the object velocity and acceleration are in the opposite direction, the speed of object now decreases with time. We may say that the object is slowing down or decelerate in its motion. So students, please remember that a negative acceleration doesn't mean the object is slowing down. For example, if the acceleration and velocity are both in negative, the object is speeding up. Deceleration means a decrease in speed, not a negative acceleration. The instantaneous acceleration is the acceleration of a particle at a particular instant of time, not during a finite time interval. It is also defined as the limit of average acceleration as the time interval goes to zero. The closer the time interval delta t gets to zero, the closer ratio of delta v over delta t gets to a fixed number, which is the instantaneous acceleration. To find the average acceleration from the graph, we need to have a graph of velocity versus time. The slope of the line connecting the initial and final velocity represent the magnitude of average acceleration. Meanwhile, the instantaneous acceleration can be calculated from the slope of the tangent to the curve of the velocity versus time graph. The explanation for both average acceleration and instantaneous acceleration can be shown from the graph of velocity versus time. As you can see here, the slope of the green line is the instantaneous acceleration of the object. Meanwhile, the slope of the blue straight line between point P and Q is the average acceleration of the object. A motion diagram is a representation of a moving object at the following time intervals, with the velocity and acceleration vectors sketched at each position. Red arrows for velocity vectors and the violet arrow are for acceleration vectors. The time interval between the adjacent positions of the car are assumed same. Diagram A shows the car moved the same distance in each time interval. Therefore, we can say that this car moved at the constant velocity and has zero acceleration. The diagram B shows the car is speeding up. This is because of the velocity of the car increases with time. This car has a constant acceleration in the direction of its velocity. And lastly, diagram C telling us about the car is slowing down or decelerate in its motion. This car has a constant acceleration in the direction opposite of its velocity. A particle moving along the straight line on the x-axis with constant acceleration can be studied on the three different graphs. The first graph is graph acceleration versus time. As you can see here, the slope is zero. This is due to the constant acceleration between the initial point to end point. When we calculate the area under the graph, we may get the velocity of the object. The second graph is graph velocity versus time. It has a straight line graph, meaning that the slope of the graph has a constant acceleration. When we calculate the area under the graph, we may get the displacement of the object. The third graph is graph position versus time. When we calculate the slope of the graph, we may get the velocity of the object. Before you start solving the problem in one-dimension motion, let's identify four kinematics equations involved. So student, please remember these four equations are used in the situation that has uniform or constant acceleration only. The first equation is v equals to v naught plus at. The second equation is delta x equals to v bar t. The third equation is delta x equals to v naught t plus half at squared. And the last number 4 is v squared equals to v naught squared plus 2a delta x. V stands for final velocity. V naught stands for initial velocity. A is for acceleration. T is for total time taken. Delta x is for displacement. And V bar is for average velocity. To understand and apply these four equations, let's do the exercise from the textbook.
Okay, so let's look at the first situation or the first videos telling you about the motions. So I think all of you have already understood in terms of how to solve a problem using positions, maybe using velocities and also accelerations. It's just you need to do some more exercise in order for you to understand or to do in during the during the problems. Okay, when you did the problems and you did the tutorials, or please make sure that you make sure you use all the equations, okay, knowing all equations in order for you to get into the problems. And if you do have a problem, please take out all the informations. Okay, in the question, take out all the informations. Maybe you can circle it, or maybe you can underline it, or you can highlight it, whatever you can. So to understand that, that it will be the informations given by the questions. And of course, in order to solve the problem, each problem, maybe you may have to use more than one equations. Okay, not just one equation to get through all the questions. Okay, so that's why at the end of the equation, at the end of the presentation, or at the end of the videos, that madam said that you need to understand the equations better than anyone can do. And of course you need to understand the situation where the questions will take place. Okay. All right, so let's recap whatever she said in the lectures. So um, watch another. Let's watch a few. Let's watch this video again, but we can um, maybe can play it.
This motion, we
Okay, so it starts with the learning outcome first. At the end of the session, students should be able to define. Okay, meaning that during your tutorial, you can also define and give definitions. Distance, displacement, average speed, average velocity, and average acceleration. Of course, you need to calculate all the values, and you need to apply the equations of motion. That will be the equations of motion. At the end of the this video, her video is the equation of motion that involve constant acceleration. Okay, the rules for using that equation, but you must use a constant acceleration. You must make sure that the question, okay, will have constant acceleration. Maksudnya pecutan mesti sekata. Okay, maksud pecutan sama, maksudnya tidak ada sebarang increase or decrease in the order of the questions. Maksudnya dalam pengiraan, in the calculations, the pecutan ataupun acceleration must be equivalent to one value. Okay, maksud dia kalau dia 8 meter per second square, so 8 meter per second square untuk keseluruhan ke, apa keseluruhan kejadian. Okay, maksudnya we cannot have an acceleration, let's say 8, maybe in middle of the question 10, and then afterwards becomes 2. No, you cannot do that. You cannot use that. You cannot apply that equation of motion with that acceleration. Okay, of course, you need to sketch and analyze the graph of displacement. Okay, displacement versus the graph of displacement. Okay, S versus T, X versus T, V versus T, and also A versus T. And you must know about what is the meaning of the um, apa the slope, and how about the area under the graph, all those things. Okay, so this part doesn't exceed in in terms of how to get that area of the graph using integrations, but you need to know how to use the uh, area under the graph, because area under the graph for the straight line graph is easy. Okay, but area under graph for the curve line graph is quite hard, because we need to do some integration. But for your level, the integrations part can be reduced, or can be exclude, because you are already given the equations. Okay, so we move to other parts. Maybe the madam already stated.
Of displacement.
Okay, starting with the displacement. Okay, anyone? Ada yang tak faham apa-apa, mungkin nak tanya apa-apa, boleh tanya terus. Sementara saya teruskan dengan displacement.
One position.
Okay, so this is displacement. Okay, what is the defined definitions of displacement? Okay, we normally put during your school days you always use S, but displacement is the x, meaning that final position minus initial positions. Okay, so F stands for final and I stands for initial. The SI unit for the displacement will be a meter. Okay. The distance is the total length of travel. The SI unit is meter, and this displacement is a vector quantity. While distance is a scalar quantity. So bila kita cerita pasal distance, maksudnya jarak lah. Jarak ialah quantity skala, scalar quantity, while displacement is the sesaran, which means the vector quantity. Okay, so this is the examples of the displacement. What is indicate the displacement in positive, and what indicate the displacement in negative. Okay, if they move at a certain position, okay, they move forward. So that means the displacement is positive. When they move backwards, okay, let's say the final point is negative 53, while the starting point is 38 positive. So meaning that the delta x should be negative 91 meters. Okay.
Positive 22 meter.
Okay. You can right. So this one is highlight also about vector and the scalar quantity.
Speed and, for example,
Okay. So this is speed. Okay. Sometimes people call this speed. Okay, because speed is the length over time, but for the total path length over the total elapsed time, we call that as a velocity. Okay, because speed is a scalar quantity, and of course the velocity is a vector quantity. You can look at the speed
every
first.
speed of an object is defined.
Okay, so normally when we try to deal with the questions regarding speed or velocity later on, maybe in this particular chapter, it will enhance what is the difference between speed and velocity, but not the other chapter. And on the next chapter, and maybe in the latest chapter, you will see that speed and velocity have a very narrow margin. So meaning that we can always state that speed is actually velocity, but velocity is also speed. Okay, on the next chapter. But in this chapter is particularly is very stressful in terms of determining or define what is speed and what is velocity, because it's all due to the directions. Velocity involve directions, while speed doesn't involve any directions. Okay, so this is the path length versus distance. Distance depends only on the endpoint. Okay, the distance does not depend on what happened between the endpoint, is the magnitude of the displacement. Now about path length, the total distance will depends on the actual road taken. Okay, this is velocity. Okay, as I mentioned earlier, okay, it doesn't have much different with the speed, but it could have, okay, a difference in terms of direction, because velocity involve um, velocity involve displacement. Okay, velocity will involve displacement, because displacement is delta x, while delta t is the uh, change in time. So change in position over change in time. Look at the two different meaning. Total path length, jarak keseluruhan, dan also jarak kita panggil apa? Uh, from last point to the minus initial points. That's what we mean by sasaran. Okay, delta x over delta t.
Unit, which is in meter.
Okay. Average speed is not the same as the average velocity, definitely. Velocity can be positive or negative, and delta t is always positive. Okay. The SI unit for the velocity and also speed is meter per second. Okay. This is the average velocity. Okay, so what is the average? Average is kalau dalam Melayu kita panggil purata. Okay, how average velocity tells us how fast something is moving and also the direction of the object. If an object is moved in a positive direction, then velocity average is more than zero. Okay, if the objects move in a negative direction, then the average velocity is much less than zero. Ada soalan ke tak? Ada soalan ke? Nak tanya apa-apa? Okay, the graph interpretation of velocity. So velocity can be determined from a position time graph, which means x versus t graph. Average velocity equals the slope of the line adjoining the initial and final points on the graph. Okay, joining the initial and final point. An object moving with a constant velocity will have a graph that is a straight line. Remember, x versus t got straight line, and the slope is equivalent to the average velocity. Because here you can see there is a change in time. Let's say in this question, the difference between x c and point A in point C is 60. Okay, because 40 minus negative 20 will be 60. And of course, the change in time will be 30 minus 0. So that will give you some value. So that value is equivalent to average velocity. Okay, this is the average velocity for the non-constant. You can see here, this is not the straight line graph. In fact, this is the curved line graph. Okay, the average velocity for this graph also is equivalent to the slope of the straight line. Okay, but how can we get the straight line from the curvy graph or curved line graph? Okay, the average velocity between any 2 points equals to the slope of the blue lines connecting the points. Okay, so meaning that we can still get the slope with this kind of graph. Okay, so this is quite new. Maybe some of you already learned about instantaneous. That word comes from the word instant. Okay, meaning that this is the instantaneous average velocity in the limit as the time interval becomes infinitesimally short. Okay, meaning that the delta t cannot be zero. Okay, when the delta t cannot be zero, because it will give a value that divide by zero will give you undefined. Okay, so you can see on the graph, or on the graph here, the slopes of the blue lines are average of the velocity which approach the slope of the green tangent line. So you need to draw a tangent line. Yeah? Do you know what is tangent? Okay, when you have a slope or maybe a curve graph, so you draw a line that can actually touch the curve. So that point is equivalent to the tangent. So therefore, from that tangent, you can use instantaneous velocity. Okay. So changing velocity means an acceleration in present. So after you learn about position, and then of course the velocity, and now you learn about acceleration. So what is acceleration? A delta v, definitely a velocity. Okay, delta v over delta time, meaning that change in the velocity over change in time. And of course the unit for the acceleration is m over s square. Okay, but believe it or not, maybe later, maybe during the dimensional analysis, or maybe during the uh, questions, when you try to answering the questions, maybe they will ask you some things that related to kilometer per hour square, for example. So kilometer per hour square is also an acceleration. But how can I know that kilometer per hour square is as acceleration? Of course, with the units. I'll try to refer it because kilometer is related to meter, centimeter, and feet. Okay, because that is length. And of course, at the denominator part will be the hour square. Hour square is the part of the time. So that is how I know that one is also acceleration. So don't get confused with the terms. And of course, if you look at the power of the seconds, okay, you must have a second square, or maybe hour square or minute square. That's all will give you as an acceleration. Okay, because acceleration is the rate of change of the velocities. Okay, of course, the average acceleration have a vector quantity. Okay, how can the things speeding up and also speeding down, okay, when the object's velocity and acceleration are in the same direction. So velocities, acceleration, same direction, so we can say that the speed, the object is speeding up. Okay, maksudnya kelajuan dia bertambah. But however, when the object's velocity and acceleration are in the opposite direction, the speed of the object decreases with time. Okay. So there's some fun facts in terms of average accelerations. Okay. A negative acceleration does not necessarily mean the object is slowing down. If the acceleration and velocity are both negative, the object is speeding up. Remember one thing, maksudnya kalau ada negative acceleration, bukan bermaksud objek tu semakin perlahan. And because of that, it's just because of the direction. If the object and velocity are both negative, the object is still speeding. Maknanya kedua-dua ke arah yang sama. The deceleration means a decrease in speed, not a negative acceleration. So kena faham jangan salah faham. Okay, so this is instantaneous acceleration. The same goes to the instantaneous velocities. Okay, the limit of the average acceleration as the time under interval goes to zero. Okay, that is only approaching zero. Okay, you cannot put delta t to become zero. Okay, when delta t gets to zero, ratio gets to fixed number, and of course, the instantaneous acceleration. We will see inside the question how to use the instantaneous acceleration and so on and so forth. Okay. So this is graphical interpretation, right? Average, what is average acceleration? Slope of the line connecting the initial and final velocity on a velocity versus time graph. And how about instantaneous acceleration? Is the slope of the tangent to the curve of the velocity versus time graph. Remember these things, okay? Average apa, instantaneous apa. Macam mana nak tahu instantaneous? Kena buat tangent. Kenapa tangent? Sebab velocity yang duduk di dalam instantaneous acceleration ni kebiasaannya velocity tu berbentuk slope, berbentuk a curve. Okay, dia bukan straight line graph. Okay, but for the average acceleration, normally they put a straight line graph. However, you must know about the slope because the slope is always referred to, for the v versus t, always refer to acceleration. Okay, so this is the average acceleration for the graphic examples. Okay, the car, let's say at figure A, the car moved with a different velocity at point P and point Q. Okay, so meaning that when the car start to increase its speed from the point V to point Q, P to Q, so we are saying that when it reach the point Q, so that will be the final answer. And when it goes out from the point P, that means that will be the initial point. Okay, the slope of the green line in the instantaneous accelerations of the car at point Q is equivalent to the slope of the blue line connecting P and Q. Okay, so slope of the green line is the instantaneous acceleration. Okay, green line tu. Tapi yang warna biru tu, slope of the blue line connecting P and Q is the average acceleration. Satu instantaneous macam mana? Tangent. Okay, average pula dia ambil macam tu lah, straight line. Daripada tempat curve tadi. Okay, so this is the motion diagram. This car move at a constant velocity. So this is a zero acceleration. Why you can say a zero acceleration, even though you can see the car is still moving? Okay, if you can really observe the car, the gap between the car is actually the same. Okay, meaning that these 5 cars is actually maintaining at one speed and one speed. But this is not the 5 cars actually, because this is just a symbolic of a car at a random position. So if as a function of time, the car move at this kind of position, so that means the car will have is zero acceleration for the constant velocity. And about part B, okay, this car has a constant acceleration in the directions of its velocity. Okay, you can see, okay, in the figure B where the car is actually at very close enough to each other, and then of course when they try to speed, okay, you can see the car is actually moving towards, okay, and of course you can see the gap is getting bigger. Okay, the gap between the car and also his bayangan dia is getting bigger. And how about the car has constant acceleration in the direction opposite to velocity, like the figure C? We can see that when the car is starting to stop, so it's actually try to reduce the speed of the car. And of course, it will show you the impact when the car stops. Okay, so this is the 1D motions of constant acceleration. Right, so a particle moving along axis with a constant acceleration, so we can state its motion in terms of the slope 0, slopes equivalent to A, and this one slopes equivalent to V, because this is x versus time. dv per dt equals to A, dx per dt equals to V. Okay, so this is the equations of motion that I'm saying just now about how to use this equation in the problems. Okay, in the earlier problems, it's only explaining about how to get to know x and how to get to know v, and of course how to get to know acceleration. So that knowledge is actually being put together so that you can use and you can crush this equation and of course try to answer the problems. Okay, so you must know, you must understand the concepts of these equations of motion. As a physicist, you must really know this equation without looking at the actual equations. Okay, please try to memorize. Okay, for those who can memorize these equations, have a big advantage with the others. While the others is still trying to find the equations during final exam, you are already submit your answer. You already answering your problems. So that will give you much time to answer. Okay, that will give you a conclusions in terms of motions in one dimension. Okay, so have you ever have any questions?
Sir, ada question.
Yes, Adam. Okay.
What's the difference between instantaneous acceleration dan
Okay.
non-constant acceleration?
Instantaneous acceleration is more uh, to non-constant. Macam tadi non-constant dia more kepada macam mana cakap tadi, uh, sekejap, saya nak guna ayat yang lebih tepat. Saya jawab yang instantaneous dulu. Instantaneous is uh, situation is where the acceleration is not constant. Okay, first acceleration is not constant and of course ada berlaku perubahan. Sekejap velocity velocity dia naik, ada masa velocity dia turun. Sekejap.
So, sir, the velocity must be curved lah. The graph, when the acceleration is increasing or decreasing.
Sekejap. Okey, apa soalan tadi? Sekejap, Adam punya soalan tadi. Non-constant tu yang bahagian mana? Adam?
Dah macam the macam
Mhm.
what's the difference kalau nak explain kan between acceleration yang apa ni instantaneous dengan non-constant acceleration, ke mereka dua benda yang sama?
Macam ni, kalau instantaneous ni normally memang dia bukan constant acceleration. Instantaneous acceleration memang acceleration dia tak constant.
Okay.
Acceleration constant ni maksud dia value dia maintain sama. Value dia maintain sama je sepanjang situation tu. So kalau value dia maintain sama, lain lah maksud dia kan. It can use our questions. Okay.
Sorry, apa ni?
Yes.
Non-constant acceleration dengan instantaneous.
Non-constant.
Macam mereka dua tu benda sama ke ataupun berbeza?
Okay, sekejap. Saya buka balik ni. Acceleration ataupun velocity sama je kan? Okay, sekejap Okay, let's look back.
X unit both totally x over n. In we plot position x, may use the formula as the change.
Okay. Kalau kita tengok dekat sini, velocity from the x versus t graph. Okay, x versus t graph, so you can get the straight line. So we have a straight line, definitely the slope will give you constant velocity. Okay, constant velocity because there is a straight line. Okay, but for the acceleration, macam ni, ataupun velocity, saya boleh ambil velocity pun boleh, nak acceleration pun boleh. Okay, so kalau acceleration biasa, acceleration lah kita calculate kan. But when it comes to graph, Okay. Okay. Untuk dalam keadaan macam ni ya, contoh Adam, this is constant acceleration. So constant acceleration maksud dia kita boleh calculate acceleration daripada V versus T graph. That is constant. Tapi kalau non-constant acceleration, maksud dia we cannot calculate the acceleration from the graph. There's no way to calculate the acceleration. That's how nama dia non-constant acceleration. Tapi kalau still macam dalam case yang kamu tengok sekarang ni, kita still boleh calculate because kita depend kepada dia punya slope. Walaupun dalam keadaan curve graph, tapi slope dia masih ada melalui garisan tangent line. Boleh Adam?
Okay, terima kasih.
Okay. Okay,
So,
next question. Yep.
Kalau yang
Yes.
yang non-constant acceleration, yang velocity tu mesti curve
Okay.
lah.
Non-constant acceleration.
Maksudnya kalau contoh
Macam mana?
acceleration berubah, macam dia macam curve, velocity tu macam mana? Dia akan curve juga ke dalam tu? Dalam graf?
Untuk macam mana? Saya nak faham balik soalan awak.
Contoh acceleration tu dia bertambah, dia berkurang. Kan dia macam menaik, menurun.
Okay.
Contoh
Untuk V versus T graph.
Lepas tu velocity.
V versus T graph ke tak? Untuk V versus T ke untuk X? Abu, untuk A versus T ke V versus T ke X? V versus T ya? Am I right? V versus T kan? Hello? Okay.
Hello sir.
Okay, apa yang saya faham pasal soalan Abu? Ya. Okay, untuk V versus T graph am I right? Okay, untuk V versus T graph, so when you draw the graph, so line dia tu, slope dia tu akan menghasilkan acceleration. Itu acceleration. Acceleration tu berbentuk constant lah, sebab kita still boleh kira acceleration for the whole. Maksudnya value dia tidak berubah-ubah.
Okay.
Okay, faham tak?
Faham.
So itu maksud dia. That's what we mean by the constant acceleration. Constant acceleration untuk V versus T graph. Okay. Tapi kalau awak tengok, kalau A versus T graph, acceleration dia, katalah acceleration dia constant, maksud dia acceleration dia kosong lah kan. Acceleration dia boleh jadi satu value yang sama sepanjang value. Tak semestinya kosong lah. It can give a slope yang kosong, tetapi acceleration can be value. Maksud dia kalau A versus T, we can get that value. Contoh dia macam graph di figure A yang saya tengah tunjuk ni, sebelah kiri sekali. A versus T graph. So ada satu slope, nilai dia kosong, tetapi bukan acceleration tu. Itu kalau tengok acceleration ada value. Dan slope dia tu tidak membawa masuk apa-apa, sebab slope yang bawa masuk ialah slope yang pada X versus T dan juga slope yang V versus T sahaja. Sebab slope X versus T dapat V, slope V versus T dapat A. Slope A versus T tak ada apa-apa masuk. Tetapi kalau kita tengok dekat sini, we can get actually the acceleration is quite constant. Nampak? Dia hanya satu straight line sahaja. One value while the time changing, but acceleration is keep constant. That's what it means by the constant acceleration. Okay. Soalan lain? Have any questions? Okay. Ada soalan lain? Soalan dia soalan yang berbentuk macam apa lagi? soalan-soalan yang lain, maybe saya boleh tunjukkan sikit. Kamu tak ada kelas pukul 1 eh? Ada kelas ke pukul 1?
Tak ada.
Okay. Saya cuba tunjukkan sikit soalan yang mana yang boleh. Okay, sekejap. Baik, dah jumpa dah. Okay, maybe kita boleh tengok these examples. Okay, nampak Nampak tak?
Yes, nampak.
Okay.
Yes.
So soal a turtle and a rabbit engage in a foot race over a distance 4 kilometers. The rabbit runs 0.5 kilometers and then stops for a 90 minutes nap. Upon awakening, he remembers the race and runs twice as fast, finishing the course in a total time of 1.75 hours. The rabbit wins the race. Calculate the average speed of the race of the rabbit. Okay, so calculate the average speed. So you taken from the questions, tengok soalan, you can actually pick out a few information. So let's say we have a distance. Okay, the total distance is 4 kilometers. Okay, 4,000 meters. The rabbit runs 0.5 kilometers and then stop for a 90 minutes nap. Upon awakening, he remembers the race and run twice as fast. Okay, so right now you should know, first calculate the average speed of the rabbit. So average speed of the rabbit is you must calculate the total length over a total time elapsed by the rabbit. Okay, so in this while using the information given, 4 kilometers divided by 1.75 hours is 2.29 kilometer per hour. Okay, 2.29 kilometers per hour. What was his average speed before he stopped for a nap? Before he stops for a nap, so the rabbit is actually running at 0.5 kilometers. Okay, and of course, it must have his already must have his speed. Okay, so dia ada speed dia tersendiri pada 0.5, and sama juga dia pun selepas itu dia ada lagi satu apa panggil, lagi satu speed, ada dua speed yang berlainan kan. So dekat situ dia buat dalam question ni, maksudnya T1 plus T2 equals to 0.25 hours. Okay, kenapa 0.25 hours? Tapi sebab consider this is only yang 0.5 km tu yang dia lari sendiri. The rest of yang dia lari tu, dia lari dengan average speed 2.29 km per hour. So that's why in here kita T1 plus T2 Okay, T2 tu 3.5 lah, 3.5 kilometers. And of course, V1 ialah V sebelum V masa 0.5 kilometer, and the rest of the kilometer dia run twice as fast. Twice as fast. So sebab tu dia buat dekat sini 2V1. Okay, 0.5 divided by V. Okay, divided by V. Kenapa kita guna D per V ni? Dia sebenarnya daripada equation V bahagi equivalent to D bahagi dengan T. Okay, displacement bahagi dengan time. Ataupun distance bahagi dengan time. So, sekarang ni dia tukar. Dia ambil time tu, kita nak cari. So, dia ambil D per V. Okay, sebenarnya ada time lah setiap satu. So, therefore, the V1 is equivalent to 9 km per hour. So, 9 km per hour. And then the average speed of the rabbit is 2.29 km per hour. Okay. Faham tak? Boleh faham tak?
Sir,
Problem
kena
ni.
tukar meter per second ke? Atau tak payah?
Buat masa ni dia tak tukar lah. Dia pakai sebab dia tak ada. Dia just tunjukkan dalam kilometer per hour.
So
Tapi kalau
dia,
perlu tukar, kita tu convert lah.
kalau ikutkan dia betul ke kalau kita tukar? Walaupun kita tukar.
Betul lah. Maksudnya bukan tukar masa tengah-tengah jalan. Tukar bila last kali. Mana
Okay.
sebab dalam soalan dia bagi kilometer dengan hour, kilometer hour je. Kan?
So unless kalau dia
nanti
baru kita tulis biasa je lah.
Nanti 90 minutes nap tu bersamaan dengan 1.75 hours. Tu dia tukar kepada hour. Dia tak naklah minit ada, hour ada. Jadi dia tak. Kalau kita nak tukar semua meter pada second pun boleh. No problem. Boleh je.
Okay. Thank you, sir.
Alright. Okay, so ada soalan lain juga dekat sini. Contoh dia, ni ambil taken from the textbook. A train moves slowly along a straight portion of track according to the graph of position versus time. Okay, position versus time. Tengok graph dia. From O to A, from A to B, dari B tiba-tiba dia naik dia naik macam curl macam tu C. Okay, ke C. The average velocity of the total trip. The average velocity of the total trip again. Okay, dapatkan value daripada berapa? 10 semua sekali kan. Daripada 0 sampai 10. Time dia daripada 12 sampai 0. So that's why 10 bahagi dengan 12. Dapat value. Okay, soalan B, the average velocity during the first 4. First 4 maksud dia first 4 seconds of the motion. So 4 divided by 4 equivalent to 1 meter per second. And now C, the average velocity during the next 4 of the motion. So next 4 sampai 12 lah, sampai 8 lah. Kan? So the next 4 berapa value dia? 0. Because tengok slope dia jadi kosong. There is no velocity to calculate. The velocity will depends on the slope. The instantaneous velocity tengok macam mana. Macam mana penggunaan instantaneous velocity. Kalau kita tengok instantaneous velocity, kalau tengok dia punya pengertian macam ada limit-limit lah apa. Tetapi bila when it comes to the real problem, dia tak nak macam tu pun. Okay. Dia sebenarnya like simple lah. Tengok dapat the instantaneous velocity at time t equals to 2 seconds. Okay. Time t equals to 2 seconds. So dekat mana tu? So what is instantaneous velocity as T? So same as the average velocity found in B. So sama juga. Sama juga dengan apa yang kita dapat daripada B. Sebab apa? Sebab dia duduk dalam perjalanan daripada kosong ke A. Nampak dia duduk betul-betul di atas line yang slope yang kita kira soalan B tadi. So that's why kita dikatakan value dia sama. Kita tak perlu calculate. Okay, untuk soalan E, the instantaneous velocity at time t equals to 9. Yes. Kalau tengok time t equals to 9, dia duduk di antara 8 dan 10. 8 dan 10. Sebab tu kalau kamu tengok ada satu garis putus-putus kali hijau ni, dia letakkan di sini. Sebab apa? Dia nak jadi tangent. Sebab that antara B ke C tu ialah curve graph. Okay, curve graph. So bila curve graph, dia nak ambil jadi tangent. So tangent, that's why kita akan cari tangent, and then of course kita calculate guna cara kecerunan macam biasalah 4.5 Okay, divide by minus 0. Dia ambil 4.5 minus 0. 4.5 maksud dia tempat ni Y. Minus 0 ke bawah. Lepas tu yang X dia 9 tolak dengan 3. So dapatlah 0, lebih kurang 0.75 meter per second. Okay, nampak instantaneous velocity ni kalau dia bagi graph tak ada masalah. Kita boleh pergi straight away dekat tempat tu. Kalau tempat tu kita dah calculate dia punya gradient, so tak ada masalah. Terus jawab je. Tapi kalau tak ada gradient, macam contoh dia ada kawasan yang curve, so we have to draw a tangent line in order for us to calculate the slope. Faham? Okay. So actually adalah beberapa ni lah. Ni contoh acceleration. Okay. But acceleration tengok dia gunakan graph V versus T. Sebab apa dia guna graph V versus T? Sebab dalam graph V versus T, slope equivalent to acceleration. Okay. Directly cakap. A baseball player move in a straight line path in order to catch a fly ball hit to the outfield. Okay. Straight line path. His velocity as a function of time is shown in the figures. Find his instantaneous acceleration at point A, point B, and point C. Tengok macam mana dia calculate. Point A, point B, dan juga point C. Ini untuk figure yang A saja, bukan figure yang belah kanan tu, figure yang belah kiri. Okay, you can state here, okay, at point A, so you actually can get the average from the average value boleh ambil 4 minus 0, 2 minus 0. Okay, because total velocity over total time, that will give you acceleration. Because that acceleration sama juga dengan acceleration dekat point A. Because it all falls under the same curve or under the same line. Daripada kosong ke atas ni. Okay. Point A tu duduk di tengah-tengah. So definitely value dia jadi 2. How about part B? Okay, how about part part B, dia nak tahu dekat mana. Okay, part B. So definitely 4 dengan 4. So atas kosong bahagi dengan bawah 1. Definitely you will get 0 instantaneous acceleration. And C, on part C dia ada negative. Of course, you should put the value negative 2 meter per second square. Don't forget about the unit. Okay, unit is always important. Okay, faham So next class, we will start doing the examples on this part. Okay, one-dimensional motion with constant acceleration, insyaAllah. Okay, and of course kita akan teruskanlah dengan pelajaran-pelajaran lain. And if you do have a problem, then please ask in the Google Classroom, or maybe boleh gunakan Island U-Future. Okay, so I think I'll stop here. Ada soalan lain tak? Kalau ada letakkan dekat komen lah. Senang saya boleh baca, saya jawab kemudian Okay, so thank you everyone. Thank you for your attention. So I'll see you during our class on Thursday InsyaAllah. Assalamualaikum warahmatullahi wabarakatuh.
Waalaikumsalam. Thank you, sir.